Another day, another story. Underfloor heating, UFH, is a heating system that is installed beneath the floor surface of a building. It is becoming increasingly popular due to its efficiency and comfort, as it provides a more even heat distribution and eliminates the need for radiators or other visible heating sources. There are two main types of UFH, electric and water-based. Electric systems use heating mats or cables, while water-based systems circulate warm water through pipes installed under the floor. Water-based systems are generally considered more efficient and cost-effective, but require more complex installation. When it comes to installing UFH under concrete, it is usually done with a water-based system, as electric systems are not suitable for this type of installation. The pipes are laid out in a network of loops, with each loop connected to a manifold that regulates the flow and temperature of the water. The pipes are usually embedded in a layer of insulation material, which helps to prevent heat loss and ensure that the heat is directed upwards, towards the floor surface. A layer of screed or concrete is then poured over the pipes to create a smooth, even surface for the final flooring material to be laid on. One of the advantages of installing UFH under concrete is that the thermal mass of the concrete helps to retain the heat, which can lead to energy savings and lower heating costs. However, it is important to ensure that the system is properly designed and installed by a qualified professional, as poor installation or inadequate insulation can lead to inefficiencies and reduced performance. Explain what can go wrong, as poor installation or inadequate insulation can lead to inefficiencies and reduced performance. There are several things that can go wrong with an underfloor heating system installed under concrete if the installation is poor or inadequate insulation is used. Here are some of the most common problems. Heat loss. If the insulation layer beneath the pipes is not thick enough, heat may escape downward instead of upward, leading to a loss of efficiency. This means that the system will need to work harder to maintain the desired temperature, which will increase energy consumption and costs. Uneven heating. Uneven heating is a common problem when the pipes are not installed correctly. This can occur if the pipe spacing is too far apart, or if the pipe layout is not optimized for the shape and size of the room. Uneven heating can create hot and cold spots on the floor, which can be uncomfortable and reduce the overall efficiency of the system. Poor quality components. Poor quality components, such as low-quality pipes or manifolds, can also lead to inefficiencies and reduced performance. Pipes that are not designed to withstand the high temperatures and pressures of the system can break or leak, while manifolds that are poorly designed may not distribute the water evenly, leading to uneven heating. Incorrect design. A poorly designed underfloor heating system can result in a variety of problems, including insufficient heating output, poor system efficiency, and increased energy consumption. For example, if the system is undersized for the room or the building, it may struggle to maintain the desired temperature, while an oversized system may waste energy and create unnecessary costs. To avoid these problems, it is important to have the underfloor heating system designed and installed by a qualified professional with experience in underfloor heating installation. This will ensure that the system is properly sized, designed, and installed with the correct materials and components, leading to efficient, comfortable heating. What's the best insulation to prevent heat loss and most efficiency? The best insulation to prevent heat loss and maximize the efficiency of an underfloor heating system installed under concrete depends on several factors, including the type of underfloor heating system, the thickness of the concrete slab, and the local climate. Here are some of the most common types of insulation used for underfloor heating systems. Extruded polystyrene, XPS, foam. XPS foam is a type of rigid foam insulation that is often used for underfloor heating systems. It is resistant to water and moisture, has a high compressive strength, and is easy to install. XPS foam insulation is typically installed directly under the pipes and between the concrete slab and the ground or substrate, and provides excellent thermal insulation. Expanded polystyrene, EPS, Foam. EPS foam is a type of insulation that is made from expanded polystyrene beads. It is lightweight, easy to install, and provides good thermal insulation. EPS foam insulation is typically installed in a similar way to XPS foam insulation, between the concrete slab and the ground or substrate. Polyurethane, PUR, foam. Pure foam is a type of insulation that is sprayed onto the underside of the concrete slab. It provides excellent thermal insulation and can help to reduce heat loss through the concrete slab. However, it is more expensive than XPS or EPS foam insulation, and requires professional installation. Mineral wool. Mineral wool insulation is made from mineral fibers, such as rock wool or slag wool. It is often used as an alternative to foam insulation, as it is non-combustible and provides good acoustic insulation as well as thermal insulation. Mineral wool insulation is typically installed between the pipes and the concrete slab, and can be compressed to fit tightly in tight spaces. Overall, XPS foam insulation is often considered the best insulation for underfloor heating systems, as it provides good thermal insulation and is resistant to moisture and compression. However, the best type of insulation for a specific underfloor heating system will depend on several factors, and it is important to consult with a qualified professional to determine the most appropriate insulation for your specific installation. Tell me more about uneven heating. Uneven heating is a common problem when the pipes are not installed correctly. This can occur if the pipe spacing is too far apart, or if the pipe layout is not optimized for the shape and size of the room. Uneven heating can create hot and cold spots on the floor, which can be uncomfortable and reduce the overall efficiency of the system. Uneven heating is a common problem with underfloor heating systems installed under concrete when the pipes are not installed correctly. The most common cause of uneven heating is incorrect pipe spacing, which can occur if the pipes are too far apart or too close together. If the pipes are too far apart, the heat distribution across the floor will be uneven, leading to hot and cold spots on the surface of the floor. Conversely, if the pipes are too close together, the heat output may be insufficient to properly warm the entire floor surface. Another cause of uneven heating is incorrect pipe layout. The layout of the pipes should be optimized for the shape and size of the room to ensure that heat is distributed evenly across the entire floor surface. For example, in a rectangular room, the pipes should be laid out in a serpentine pattern, with each loop covering a different section of the floor. In a circular or irregularly shaped room, the pipe layout may need to be more complex to ensure even heating. Uneven heating can create uncomfortable hot and cold spots on the floor, which can be especially noticeable when walking barefoot or in socks. It can also reduce the overall efficiency of the system, as the system may need to work harder to maintain a consistent temperature across the floor surface. This can lead to increased energy consumption and higher heating costs. To avoid uneven heating, it is important to have the underfloor heating system designed and installed by a qualified professional with experience in underfloor heating installation. The professional should take into account the size and shape of the room, the type of underfloor heating system being installed, and the insulation used beneath the pipes. Proper design and installation will ensure that the pipes are spaced correctly and laid out in an optimal pattern to provide even heating across the entire floor surface, leading to maximum comfort and efficiency. Tell me, what is poor quality components? Poor quality components, such as low quality pipes or manifolds, can also lead to inefficiencies and reduced performance. Pipes that are not designed to withstand the high temperatures and pressures of the system can break or leak, while manifolds that are poorly designed may not distribute the water evenly, leading to uneven heating. What to look out for on poor designed UFH? When it comes to underfloor heating, UFH, poor quality components can have a significant impact on the performance and efficiency of the system. Here are some things to look out for to identify poor design or low quality components in an UFH system. Inefficient manifold design. The manifold is the central hub of the UFH system, and its design plays a critical role in ensuring even distribution of the heated water throughout the system. A poorly designed manifold can lead to uneven heating, inefficient operation, and increased energy costs. Signs of an inefficient manifold design may include inconsistent temperatures across the floor, cold spots, or excessively hot spots. Thin or low-quality pipes. The pipes used in an UFH system are typically made of high-density polyethylene, HDPE, cross-linked polyethylene, PX, or polybutylene, PP, materials. If the pipes are too thin or made from low-quality materials, they may be more susceptible to damage or leaks, which can result in significant repair costs and inefficient operation. Signs of thin or low-quality pipes may include visible wear and tear, leaks, or system malfunctions. Poor insulation. Insulation is an important component of an UFH system, as it helps to minimize heat loss and maximize energy efficiency. Poor insulation can lead to higher energy bills, reduced performance, and increased wear and tear on the system. Signs of poor insulation may include cold spots on the floor, uneven heating, or visible damage or wear to the insulation material. Inadequate control system. The control system is responsible for regulating the temperature and operation of the UFH system. If the control system is inadequate or poorly designed, it can lead to inefficient operation, higher energy costs, and reduced system performance. Signs of an inadequate control system may include inconsistent temperatures, difficulty adjusting the system settings, or frequent system malfunctions. Overall, it is important to work with a qualified professional with experience in UFH design and installation to ensure that the system components are of high quality and properly installed. A well-designed and properly installed UFH system can provide efficient, comfortable heating for many years, while a poorly designed or low-quality system can result in significant repair costs and inefficient operation. Tell me 20 ways to prevent this incorrect design. A poorly designed underfloor heating system can result in a variety of problems, including insufficient heating output, poor system efficiency, and increased energy consumption. For example, if the system is undersized for the room or the building, it may struggle to maintain the desired temperature, while an oversized system may waste energy and create unnecessary costs. Here are 20 ways to prevent incorrect design and ensure a well-designed underfloor heating (UFH) system. Hire a qualified professional with experience in UFH design and installation. Ensure that the UFH system is properly sized for the room or building. Consider the type of building, insulation, and flooring materials when designing the system. Ensure that the pipe spacing is optimized for the room size and shape. Choose high-quality materials, such as HDPE, PEX, or PV pipes, and quality manifolds. Ensure that the system is properly insulated to prevent heat loss. Avoid sharp bends or tight turns in the pipe layout, as these can reduce flow and decrease efficiency. Use a high-quality control system with accurate thermostats and reliable programming. Ensure that the system has proper ventilation and access to air to avoid overheating. Consider using a heat source that is appropriate for the system, such as a heat pump or condensing boiler. Ensure that the system is properly installed and tested before use. Use a pressure testing kit to verify that the system is leak-free and has no defects. Ensure that the system includes adequate expansion and contraction joints to prevent damage to the pipes. Ensure that the system has adequate drainage to prevent water accumulation. Consider using a system with multiple zones to allow for individual temperature control in different areas of the building. Ensure that the system is properly balanced to ensure even heating throughout the building. Avoid installing the UFH system under heavy or immovable objects, such as a bathtub or large cabinets. Ensure that the flooring material is compatible with the UFH system. Consider the long-term maintenance requirements of the system when designing the system. Ensure that the system is designed to meet local building codes and regulations.